right, so we're starting on part 2. It starts with number 5 because we ended with number 4 yesterday, and we're going to be graphing some more rationals. So we start off by factoring again, and then the numerator I can factor out an x squared. That leaves me with x plus 2. And the denominator, part of it's factored out already, but I got to do the rest. So I'm going to have 2 more down here. So this is going to give me x, and that will give me a positive 6 and a negative 3. All right, so do I have any holes in this function? No. But am I finished rewriting this? No, because look, I got an x minus 3 and an x minus 3. So I need to make this f of x equals x squared times x plus 2 all over x minus 3 squared times x plus 6. Okay. All right, so this is the function that I'm focusing on now, or this is the version of it that I'm focusing on. I do not have any holes. My roots, I get those from the numerator, so they are negative 2 and 0. The vertical asymptotes come from the denominator, so they are negative 6 and 3. Tangency and togetherness. I have both here, right? Because I have exponents in the numerator and in the denominator. So does the numerator give me tangency or togetherness? Tangency. Always say them together and you won't mess with tangency and togetherness, numerator, denominator. So I have tangency in the numerator, and that happens here. So that happens at x equals 0. And then I have togetherness from the denominator. That happens here, so that happens at x equals 3. Oh, and I'm such a dork. Look what I did with my vertical asymptotes. Is this how we write vertical asymptotes? Y'all don't even stop me. Y'all haven't been paying attention. I don't get to write them like that. What do they have to be? Yeah, they're lines, so I have to write them as lines, and I don't even know what happened there with my brain. So let me redo that. I get x equals negative 6 and x equals 3. There we go. That's how you really write asymptotes. All right, and we're good with the tangency and togetherness too now? All right, so then our horizontal asymptotes. Do we have any? Is this top heavy, bottom heavy, or tied in degree? Tied in degree, right? Because it's a cubic over a cubic. So if it's tied, I do have 1. And it would be the ratio of the leading coefficients, so it's 1. Which means there's no slant asymptote. What's my y-intercept? No, it's 0 something. It's f of 0, right? So I just substitute in 0 for x. What happens as soon as I do that up here? I get 0 in the numerator, so it's 0. Anytime you have an x-intercept that's 0, then your y-intercept is going to be 0 as well. All right, so then I'm going to rewrite this so I can see it when I scroll. F of x equals, do x squared times x plus 2 all over x minus 3 squared times x plus 6. Okay. All right, so now I'm going to scroll, and we're going to take care of our number line. So on here, I'm going to have 4 things on here. I'm going to have the negative 6, the negative 2, the 0, and the 3. All right, the negative 6 is open, negative 2 is closed, 0 is closed, 3 is open. Okay. So remember on the last one we talked about yesterday was the fact that our sign chart's always going to alternate unless we have tangency or togetherness. So we don't necessarily have to think through each piece every single time. So but we do need to get the first one. So let's get the first one here. And I have negative 7. Anytime I square it, it's going to be positive. This is going to give me a negative. And then I'm going to get a negative squared, so it's positive, and negative again. So this is positive overall. Do we all agree with that? All right, so now I could figure out the rest, but I can also think about what is happening here. At -3, that's where I have my togetherness, right? Oh, goodness. Okay, that's where I have my togetherness. And then, so I know these two are going to be the same. I also have tangency here, which means there's a bounce here. And if there's a bounce here, they're either both negative or they're both positive. So these two signs have to be the same, and these two signs have to be the same, which means all these are the same. There's no tangency or togetherness here, so this alternates. It's negative. No tangency or togetherness between here, so it's positive. Since there's tangency here, it's positive, and since there's togetherness here, they have to be the same, and it's positive. If thinking through it that way is confusing to you, there's nothing wrong with just doing the sign, because we still need the sign chart. There's nothing wrong with actually figuring out the signs. But if I positive, negative, positive, 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 okay? Because what's happening with my function here, this is an asymptote as well, so it has to be positive, so it looks like this. There's no togetherness here, so we have to start down here, right? This is going to have to become positive. Since I'm here, this is going to have to be a positive. Here's my bounce, and it goes up like this. This is my togetherness, so they have to be going in the same direction that way. And that basically gets you your little pieces of your graph. Okay, kind of a generic, this is what's happening, and then we'll get it on the actual graph itself. So let's plot what we actually know. We know that there are no holes. We know we have zeros at -2 and 0. We have vertical asymptotes at -6 and 3. And then we have tangency and togetherness. We'll come back to that. We have a horizontal asymptote at 1. And we have a y-intercept at 0, which is already there. Okay. All right. So to look at this again, I'm going from -infinity to -6, and it's positive. So it's going to be like this somehow, but I don't know if I cross this asymptote or not, so we'll come back to that. And then I'm from -6 to -2, it's negative, so that makes sense. It's down here. From -2 to 0, it's positive, so it's just going to come up a little bit, but maybe it comes up over the asymptote, not sure yet. And then I'm going to bounce here, right? That's my tangency, and then it's going to stay positive. So clearly I have to intersect the asymptote here somewhere, right? Then from 3 to infinity, it's positive, so it's going to have to be something like this, because this is where my togetherness is, right? But again, I could cross the asymptote. Well, you're going to have to figure that out. So before I do that, I need some points in the far sides of my graph. So let's try let's see, this is at -6. Let's try -7. Okay, so I'm going to substitute in a -7, see if I can find a y value. So when I do that, -7 squared is 49. And then -7 plus 2 is -5 over -7 minus 3 is -10 squared is 100. And then -7 plus 6 is a -1. Okay, so before I start just multiplying stuff out, I'm going to simplify things. These both become positive. 5 goes into 5 once, goes into 120 times. So that leaves me with 49 over 20, which isn't a beautiful number, but 20 goes in there twice with 9 left over, so it's almost 2.5. And estimating on this graph, 2.5 is close enough. So -7, and then 1, 2.5. And I feel like that point's enough to help me with my curve, right? So I need 1 point over here. I'll choose 1 on the other side. We'll go with a +4. So when I substitute that into here, that's going to give me 4 squared is 16 times 6 over 4 minus 3 squared is 1 times 10. Right? So I can divide this by 2 and get 5, divide this by 2 and get 8. So I get 8 times 6 is 48 over 5. So if I go to 4, and then that's 48 over 5. So 5 goes in there 9 times with 3 left over. So it's about 9.5 right here. So I can get that on my graph, but I don't know if that really helps me with my curve very much. So I could try 5, but that might not get me very far. So we're going to jump to 6 and try 6 and see what happens. When I substitute 6 in and I square it, I get 36 times 8 over 6 minus 3 squared is 9 times 12. Okay? So instead of just multiplying that, I'm going to reduce some things. I know 36 divided by 9 is 4, so that's nice. Then I can divide both of these by 4 and get 2 and 3. So I have 2 times 4, which is 8 over 3. So then I can go to 6. That will give me 2 2/3. So I'm right about there. So I feel like that's good enough. So I really need to check to see if this function crosses the asymptote. So this one gets a little crazy and weird, and that's not what we need to be focusing on. You need to know you're supposed to check them, but I'm not gonna give you any more that are like crazy weird. And this one you have to end up using quadratic formula and its yucky numbers and all that good kind of stuff. So I'm just gonna tell you what happens when we check it. When we check it, it intersects it twice. We know it has to intersect it right here for the graph to make sense. The other place it crosses is at like a -15. So this graph would come down, and wherever -15 is, basically it would come down underneath it and then come right back up and stay underneath. But that's so far off our graph, we can't get there anyway, so we're not going to worry about it. And this part just comes down and looks like this. Okay. Then remember here, I'm starting down here. It becomes positive here, but it does not cross the asymptote, so it's just a little bit positive. It bounces, and then we have to cross here to come back up. So it's going to look like this. We're going to come here, becomes positive, bounce, and back up. Make that a little bigger if the bounce looks better. Then I have my togetherness, which makes sense. So this is going to have to come down, and I know I'm not crossing the asymptote over here. And it looks like this. Okay. What questions do you have? Hopefully you're seeing that, you didn't have any clue it was going to look like that when you started, but after you find all of your pieces and think about how they work, it's the only thing that makes sense for you to actually draw. Any questions at all? Okay. Then let's look at number 6. Alrighty, so for number 6, I'm going to need to factor. So you can factor by grouping on these things, but I'm going to talk you through the other graphing. This again. I'm sorry, not the other graphing, the other factoring. You can factor by grouping. I don't even know what I said. Sorry. So when I factor this, I have a leading coefficient that's not 1, and I can't factor it out. But I know since this is a prime number, this has to be 2x, and this has to be x. This is negative, so the signs have to be opposite, but I don't know which one goes where just yet. My options to go here for numbers are either 9 and 1 or 3 and 3. Well, I'm going to have to get this 3x in the middle. So I'm thinking 9 and 1 is probably not going to work, so I'm not going to start with that. I'm going to start with the 3 and the 3. Okay, so if I have 3 and 3 here, I can do 2 times 3, which is 6, and 3 times x, which is 3. And since I want to end up with 3, I need my 6 to be positive, so this would have to be a positive 3, and I need this to be negative. Then I can check myself. This is a negative 3x, positive 6x. That's what's going to give me this. And then negative 3 times 3 gives me negative 9. There you go. Okay. But again, if you need to do grouping, that's absolutely fine. I'm not saying you have to do it that way. It'll just save us some time right now. Can I factor the denominator at all? No. So it's just x squared plus 3. And then this is the version that we're going to focus on. So do I have any holes? Anything I can cancel out? No. The roots come from the numerator, so I have that. That is -3 and 3/2. Vertical asymptotes come from the denominator. So I have a variable in the denominator, but if I set x squared plus 3 equal to 0, then I get x squared equals -3, and then I would have imaginary numbers, and I can't have imaginary asymptotes, so basically I don't have any vertical asymptotes. This is none. Okay, and this is kind of unique for a rational function, because when we first started talking about them, one thing I said was that most rational functions have restrictions on the domain. This one does not, because the things that restrict your domain are the wholes and the vertical asymptotes. We don't have either one, so this is actually going to be a continuous function. Now, tangency and togetherness. I do have an exponent, but it's not a factor that's being squared. These are the factors. This is what would have to be squared. So the fact that there's a squared there, that really doesn't do anything for me, so I don't have any tangency or togetherness either. Do I have a horizontal asymptote? Yes, they are tied in degree, so it is the ratio of the leading coefficients, so it's y equals 2. Slant asymptote, that would be none. Y-intercept, well, I can just look at the constants of my function here, and I'm going to get 0, -3. And then I'm going to rewrite this. Everybody good so far? All right, so I'm going to scroll. We're going to look at our sign chart here. So I only have two things to put on here because I don't have any vertical asymptotes. So I'm going to have a -3 and a 3/2. All righty. So we have, these are both closed because they're both zeros. So I'm going to have -4. That'll give me negative minus negative, so that's negative. -4 here will give me negative. When I square it, it becomes positive, so that's positive. So that's positive overall. I do not have any tangency or togetherness. And so then I'm going to alternate negative, positive, since there's no tangency or togetherness. And this is positive, negative, positive. Okay. So then let's graph on here what we know how to graph. We have no point discontinuities. We have roots at -3 and 3/2. We have a horizontal asymptote at y equals 2. We have a y-intercept at 0, -3. Okay. So let's think through what has to make sense here. From -∞ to -3, the function is positive. Okay, and I have this asymptote here, so a couple different things could happen. It could stay underneath the asymptote like this, or maybe it's up here and then it has to cross to come down here. We're not real sure. But then from -3 to 3/2, it's negative. So then from here on, it becomes positive. So again, it could come up here and stay underneath, or it could come up here above it and then come back. On either way, the sides don't go like this. Like that's not a possibility because you still have to be approaching the asymptote at the ends. So that means we have to check to see if it actually crosses the asymptote or not. So I'm going to take my unfactored function, okay, where this came from, which was 2x squared plus 3x minus 9 over x squared plus 3. And we are going to set it equal to the asymptote, which happens to be 2, so that we can see when they have the same value. So I'm going to multiply both sides by the denominator. So I'm going to rewrite the left-hand side. When I multiply this, I'm going to distribute that 2, so I get 2x squared plus 6. So now I can start solving. I'm going to subtract 2x squared from both sides. I'll add 9 to both sides, so I get 3x equals 15, which means x equals 5. So that tells me I do cross the asymptote, and only once, and it's when x equals 5. So if I go to x equals 5, 1, 2, 3, 4, 5. When x equals 5, y is 2. So that's where we're crossing the asymptote, and that's the only place. So when I go to sketch this in, that tells me over here I have to be underneath the asymptote the whole time. So it's going to come down here. Oops. I'm going to cross here. Then it's going to come down and hit this point and come back up here. Then it's going to become positive, but I am going to cross over the asymptote. But when I do, it doesn't shoot up here. It goes back down like that. And this should be curvier, not point. Oh my goodness. Okay, I'm going to start over on that. I think I need to do it all in one motion for me to be able to handle any of it. So something like this. Okay. What questions do you have? You have to just talk yourself through it like I'm talking you through it. Like what has to happen here and what has to happen here, because what you'll find is there's only one thing that could possibly happen. Okay. Any questions at this point? Alrighty, let's look at number 7. So number 7, I need to factor. What does this one have that most of them haven't? When I factor. What can I factor out of the numerator? Can I factor out a GCF? And if you can, you want to. I mean, I can factor it without factoring out a GCF, but it makes it more complicated. So I can factor this 3 out. That leaves me with x squared plus 3x minus 4. In the denominator, I'm going to get x and x. This will be plus 2 and plus 2. So I got to keep going. F of x is equal to, so in the numerator it's going to be 3 times, then I'll have 2 binomials, x and x. I'll have to be a positive 4 and a negative 1. And then what do I write for the denominator? Good, x plus 2 squared. So this is the function that I'm going to focus on, or the version of the function. I have nothing to cancel out, so there's no point discontinuity. Roots come from the numerator, so it's going to be negative 4 and 1. Vertical asymptotes come from the denominator. Let's see if I can write it correctly this time. That would be x equals negative 2. Tangency and togetherness. Well, I have an exponent and it's in the denominator. So is that tangency or togetherness? Togetherness, good. So that togetherness happens at x equals negative 2. My in behavior, horizontal asymptotes, these are tied in degree. So I do have one, right? I look at the ratio of the leading coefficients. So it's y equals 3. None for my slant asymptotes. Y-intercept, I can look at the constants, so it'll be 0 and then negative 3. And then I'm going to rewrite my function. F of x equals 3 times x plus 4 times x minus 1 all over x plus 2 squared. Any questions at this point? Oh, good. All right, so we've got 3 things that go on my number line. Got a negative 4, a negative 2, and a 1. The negative 2 is open. These two are closed. So I have to figure out this first one. So if I substitute in a negative 5, the 3 does nothing for my signs. If it was negative, it would, but it doesn't. So negative 5 in here is going to give me negative, negative, has to be positive in the denominator, so that's positive overall. Then I'm going to alternate until I hit my togetherness. I have togetherness here. So these are the two that have to be the same. So if this is negative, if this is positive, this is negative. So then this has to be the same, and then this becomes positive. Again, if that's getting all weird for you, then you can always just go through and figure all of them out, and there's nothing wrong with that. But that's what this is going to look like. Okay. So let's plot what we can plot here. I've got roots at negative 4 and 1. And I have vertical asymptote at negative 2. I have togetherness there also, but we'll come back to that. Horizontal asymptote at y equals 3. Y-intercept at 0, negative 3. Okay. All right. So from negative infinity to negative 4, the function's positive. So again, it could look like this. Maybe it's above the asymptote. We're going to have to figure that out. From negative 4 to negative 2, it's a negative, so it comes down here. All right, that's good. Then from negative 2 to 1, it's negative, so it comes up like that, and that makes sense because here's where my togetherness is, right? And then from 1 to infinity, it's positive, could come up over this, or maybe it stays underneath. That's something that we've got to figure out. So I feel like the points that I have, they're enough. I don't think I have to put any more points on there to get the graph, but I do have to figure out whether or not we cross the asymptote. So I need my original function here. So that's 3x squared plus 9x minus 12. All right, so I've got 3x squared plus 9x minus 12 over x squared plus 4x plus 4. So that's the original one. I want to know, when does that function cross the asymptote? If it does, so I'm going to set it equal to the asymptote, which is 3. So I'm going to rewrite my numerator, 3x squared plus 9x minus 12. I'm going to multiply both sides by the denominator, and when I do that, I'm going to distribute at the same time. So I'm going to get 3x squared plus 12x plus 12. So now I'm going to start to solve. I'm going to subtract 3x squared from both sides. They zero out. I'm going to subtract 9x from both sides so that I get a 3x over here. Right? And then I'm going to subtract 12 from both sides so I get a negative 24. So that means x equals negative 8. So I do cross the asymptote. Cross the asymptote when the x value is negative 8. So I can go to negative 8, 3. There's where I intersect it. So now I can go back and sketch this in because I know this is close to the asymptote, comes down here and remains negative like that. Then over here, here's my togetherness. It's negative, then it becomes positive, but I stay underneath the asymptote over here. What questions do you have? Well, good. All right. I know, it's just a bunch of graphing. We got one more. All right. Last one. So I need to factor since there's also a mistake on this one. I left on, this shouldn't be x squared in the denominator, it should just be x, so just mark out that squared. So so I need to factor f of x is equal to, in the denominator, I get I'm sorry, in the numerator, when I factor, I get x, and this is going to be net minus 4 and positive 3. Sorry, I'm having this bad moment that I feel like I meant for this to be something else, but maybe not. Okay, and then down here, this is x minus 1. And then this is x plus 2, x minus 2. Okay, that's correct, I think. Alrighty, so then I need to figure out what's going on here. Do I have any holes? No, I have no holes. My zeros are -3, 1, and 4. Vertical asymptotes come from the denominator, so x equals -2 and x equals 2. Do I have any tangency or togetherness? No. Do I have a horizontal asymptote? No. Which opens the door for a slant asymptote. And is the numerator 1 degree higher than the denominator? Yes, it is. So I'm going to need to divide. Will I be able to do synthetic division? No, I can't, because this is going to end up being x squared. Like, what does this end up being right here? Good, x squared minus 4. So I'm going to have to do long division, which means on the outside of my long division, I have x squared minus 4. On the inside, I have this all multiplied together, which, to save time, I'm just going to tell you what that is. That is x cubed minus 2x squared minus 11x plus 12. So basically, I would need to multiply these two things together, and that's what you end up when that happens. So we're going to divide. X squared goes into x cubed, x times. This gives me x cubed minus 4x, so it's got to go over here. Change my signs. So I bring down this negative 2x squared, and then this becomes minus 7x, and then plus 12. So x squared goes into negative 2x squared, negative 2 times. So negative 2x squared plus 8. And then that's going to give me a remainder. I don't even care what it is because I'm not using my remainder. This is what I need. Y equals x minus 2. That was the same slant asymptote we had on the other problem. That's a coincidence. That's not always the equation of every slant asymptote that exists. All right, so then I need my y-intercept. So I can substitute it in different places, but what I gave you, like if this is the numerator and this is the denominator, and we're just looking at the constants, it would be 12 divided by a negative 4, right? So it's just a negative 3. Here for my number line, I definitely want the factored version, so f of x equals x minus 4 times x plus 3 times x minus 1, all over x plus 2, x minus 2. So given how much stuff we have to write on the number line, it's nice that we know when we can just alternate, but I need to put them all on there. So I have 5 things I have to put on there. I'm going to start with negative 3, then negative 2, then 1, 2, and 4. So then the 2's are open, the rest is closed. I don't have any tangency or togetherness, so basically I just have to figure this first one out. So this, if I use negative 4, this will give me negative, negative, negative over negative, negative, which is negative overall. Then, since there is no tangency or togetherness, I've got negative, and it just alternates. Positive, negative, positive, negative, positive. Then let's plot everything we can here. We've got negative 3, 1, and 4. Those are my zeros. My vertical asymptotes are at negative 2 and 2. There's no tangency and togetherness. I have a slant asymptote. The y-intercept for that is negative 2, and the slope is 1. So remember, I can just go to negative 2, and then I'm just going to go diagonally through my squares to get that on there. And then I have a y-intercept at 0, negative 3. Okay. So this looks like a hot mess of stuff, but I bet I can figure out what it's supposed to look like pretty easily here. The negative, from negative infinity to negative 3, so from negative infinity to negative 3, it's negative, so I've got this slant asymptote. It's going to have to come up like this, all right? And then from negative 3 to 2, it's positive. From 2 to 1, I'm sorry, from negative 2 to 1, it's negative, right? So that makes sense because I've got this. So I'm going to have to come up from here until there it's negative. So clearly I'm crossing the asymptote right there. Then from 1 to 2, it's positive. So it's going to have to come down here like this. And it has like there has to be a point of inflection because it's not a line. And then from 2 to 4, it's negative. So it's going to have to come up here. And then from 4 to infinity, it's positive. So I don't feel like I need any other points or anything because it's going to have some sort of curve like this when it goes through or goes next to the slant asymptotes anyway. So this part, I can go ahead and just sketch this in like this. This is the part where we have to be careful because it can't just be a straight line because I have to come down here, it's some sort of curve, and then I have to curve through these two to come back down like this. So it's going to have to kind of have we don't know exactly where the point of inflection is, but you see it has that little wiggle, kind of like a cubic does. If you have two vertical asymptotes in between them, the only two things that can happen is that it has to have a wiggle like a cubic, or it's a parabola, or it looks like a parabola. Those are the only two things that could happen. And then since I don't have any togetherness, I know I'm not up here, plus I have this point, so it looks like this. And I'm just going to tell you this is the only place that we would cross the horizontal asymptote, just for the sake of time. Okay. What questions do you have? Okay, so technically there's not an assignment that goes along with today. Because on Monday, I plan just all period, you just have the opportunity just to graph some of these. So if you want, and one thing that could be helpful to you is if you go into Monday's folder and get that assignment that's in there, if you went ahead and started on that, then whatever questions you have, you could get covered on Monday, or you can just graph all period on Monday, like whatever. I mean, but if you got a little bit of ahead of it, then that would help you in class because I could just help you with it, okay? What questions do you have? Anything? Because on that one, you're going to be graphing on Cami or on paper or whatever you prefer to do, but it's there for you to look at now, okay? Any questions at all? Awesome.